Good day everyone, welcome back to this channel. Today I want us to do the resultant force, and some call it the resultant vector. So let's look at the first one. We have a force that is pushing this, or that is pulling this object to the right, and we have another force pulling this object to the left. So where will this object move? Will it move to the right, or will it move to the left? Since we have more force on the right and we have less force on the left, we can safely say that this object will move to the right. So what is the resultant force acting on this object, or what is the net force acting on this object here? So to calculate that, we choose direction. So let's choose to the right as positive and anything going to the left as negative. So to calculate the resultant force here, we will say, let me write over here, we have a 40 Newton force going to the right, so we'll say 40. We have a 25 Newton going to the left, so minus 25 here. So the resultant force will be 40 minus 25. I'm gonna need my calculator for that. So we have 50. There's 50. Remember that force is measured in Newton. So as you remember from grade 11, that force is a vector quantity. It has a magnitude and direction. So what is the direction of this 50 Newton here? Of course, it's to the right. To the right, or you can say east. It's the same thing. So let's do number 2 here. We have this force here of 5 Newton is pulling this object to the right, and we have a force here of 3 Newton is also pushing this object to the right. So what is the resultant force acting on this object, and where will the object go? Will it go to the right, or will it go to the left? Since these two forces are going in the same direction, that means we can safely say it will move to the right. So I'll choose to the right as positive, and I will say the resultant force will be 3, it will be 5 plus 3 is 5 plus 3, which is equals to 8 Newton to the right. To the right. And here we come to number 3 here. So what is the resultant force here? We have a 70 Newton force going at an angle of 30 degrees, and we have a force of 50 Newton going to the left, and someone will just say, since we have 70 Newton here, this box will move to the right. But remember that this 70 Newton force, it is just at a random direction. It is not specific. So this force here of 70 Newton, it is kind of pulling this object to the right and also pulling it upwards. So it has no specific direction. For us to find the force that does work here, we have to use the f of x, the force in the x direction. So how do we find the force in the x direction? We say the force in the x direction is f stands for force times cos theta here. Cos theta. This theta here is 30 degrees, so we can substitute everything here. We can say it's equals to 70 cos of 30 degrees is equals to, let me take my calculator, it's 70 cos of 30 degrees. It gives me 60.62 Newton. So since 60.62 is greater than 50, we can safely say this object is going to the right. So remember that we still have another force pulling this object upwards. So how do we find that force? We say that force in the y direction. Remember, it is pulling this upwards, so we say force in the y direction is F times sine theta, like this. Since we have everything, we can substitute it. We can say 70 sine 30 degrees, like this here. And by doing that, I get 70 sine 30. I get 35 neutron. It's very hot in here. I get 35 neutron. Is equals to 35 neutron to let's say upwards. And how do we find the resultant force? Let's do the sum in the x direction first. So what is the net force acting on this object in the x direction? Of course, we'll say 60.62 minus 50. We will be left with 10.62 neutron to the right, like this here. We can say sum of forces in the x direction is equals to 60.62 minus 50 is equals to 10.5 or 10.62 neutron to the right, like this here, to the right. And since we have the only force acting vertical, we can use the Pythagoras Theorem. It says that F net squared is equals to sum of forces in the x direction squared plus sum of forces in the y direction squared. Since we have everything, we can substitute it. We can in the x direction we have 10.62 squared plus in the y direction we have only 35, so it's 35 squared is equals to, let me take my calculator and work that out. So it's square root of 10.62 squared plus 35 squared gives me 36.58 neutron. So what is the direction here? We can use the trigonometry to find that direction. You can use tan theta. Tan theta is equals to forces in the y direction over the forces in the x direction. So we can say it's equals to forces in the y direction is 35 and forces in the x direction is 10.62. You can do the inverse tangent of this here. You can say, I hope you can see here, it's shift inverse tangent, and you press this here and you say 35 over 10.62, and we get a value of 73.12 degrees. So this is your resultant force here. And yeah, let's do the last one. I think this one will be a little bit helpful to understand here. So let's do number 4 here. And number 4, we have a force here. This is downwards and this is a little bit upwards. So how do we calculate the resultant force here? Well, we can, excuse me for a little bit, sorry about that. It's very hot in here. I was going to get a fan, but hey, it makes a lot of noise, so I will continue with this one here. As I previously mentioned, this is 30 neutron in a diagonal way, and this is, or let's say 25 degrees here. 20 degrees here and 25 degrees here. This is 20 Newton, this is 30 Newton. 20 Newton is at an angle of 25 degrees and 30 Newton is at an angle of 20 degrees here. So how do we calculate the resultant force? We will look at the forces in the x direction first and the forces in the y direction first. So if we draw a free body diagram for this, it will be like this here. So this dot here represents this object here, and this force here of 30 Newton is pushing this object a little bit to the right and a little bit upwards. And let's look at this force here. It's also pushing it a little bit to the right. So we can say a little bit to the right, like this here. I should have used a ruler. And a little bit a little bit downwards, like this here. And we want to calculate the resultant force here. So to calculate the resultant force, we will say, let's look at the forces in the x direction first. Since they are going in the same direction, we're gonna add them. So we're gonna say sum of forces in the x direction is equals to, let's start with this 30 Newton first. So we're gonna say 80 cos 20 degrees plus 20 cos 25 degrees, 20 cos 25 degrees here. And I need my calculator for this. I'm gonna say 30 cos 25 plus 20 cos 25, and I get an answer of 45,32. As you can see there, 45,32. 45,32 Newton to the right as here. So when we look at the forces in the y direction, let's choose upwards as positive. So since they are in opposite direction, we're gonna minus them. So we're gonna say sum of the forces in the y direction is equals to, okay, let's say this is positive and this is negative. So we're gonna say 30 cos, no, not cos, sorry. Since we are dealing with y, we're gonna use sine. So we're gonna say 30 sine 20 degrees minus 20 cos 25 degrees, like this here. So let me take out my calculator and work it out. So it's 30 sine 25 plus 20 sine 25, 20 sine 25, 20. And please verify this for me. If they are not correct, you should correct me in the comment section. Here I get a value of 18,71 Newton upwards. Let me verify this here. I'm not sure about it, so let me verify it. And I get a value of, let me see, it's 46,32. I knew this was not correct. 46,32 Newton to the right. Yeah, please verify this, all of this for me. Sometimes I make silly mistakes, but I think you can see them. And how do we calculate the resultant force here? So we're gonna use the Pythagoras theorem. We're gonna say F net squared is equals to sum of the forces in the x direction squared plus sum of the forces in the y direction squared. So we're gonna say it's in the x direction, you say is 46,32, 46,32 squared plus 18,71, 18,71 squared. So you just take the square root of this. Let's see here. Square root of 46,32 squared plus 18,71, and please verify this for me. We have 49,96, 49,96, 49,96 Newton. This is the resultant force. So let's find the angle of the resultant force using tan theta is equals to forces in the y direction over forces in the x direction. So we have forces in the y direction is 18,71 over in the x direction is 46,71, 46,32 rather, and you say the inverse tangent of this, inverse tangent of 46,32, you say 46,32 over 18, no, it's 18,71, 18,71 over 46.32. So we find the angle here, it's 21,995. So I'm going to convert it to 22. So I'm going to write 22 degrees, and you can write anti-clockwise. So we can say 22 degrees anti-clockwise, or we can say to the negative x-axis. Yeah, I think this is it for the summation of vectors. All you have to do is choose direction, and any angle that is, any force that is, it is at an angle, you break it down into its x and y components before you can solve these questions here. Like here, you cannot say 70 is greater than 50 because this 70 here is at an angle. It's not straight, it's at an angle. So this 70 Newton, all of it does not do work. The one that does work is the one that is the x direction. So to find that in the x direction, we use cos theta. And thank you for this video. I will see you in the next one. Bye.